Kagiso? Can you hear me? Kagiso? Can you hear me? Can you hear me? Can you hear me? Can you hear me? Kagiso, can you hear me?
Yes, I can hear you.
Okay, was there a problem initially?
No.
Okay. Mom, son, how are you?
Good, thanks, and how are you, sir?
Good, thanks, yes. So today I'm gonna start by doing a question that I was sent by Kagiso. It's gonna be a bit short. I think it's very short. Kagiso, was it today's homework?
No, it was the 29, so we didn't do correction.
You haven't done corrections yet.
Yes.
Okay, now let's see what we have on it. Okay, the box given below moves to the right at a constant speed across a smooth horizontal surface. What are keywords on the statement that I've just read? Which one is the keyword? Constant speed. So if you are given that your system is moving at a constant speed, what comes to your mind in terms of Newton's law?
Let me guess. I think like the F not is equal to 0.
That's perfect. Now, draw the labeled free body diagram of all the forces acting on the box. So we'll start by a dot. So if we have a dot, does your body have a mass? Yes, it does. So what are the forces that are acting on your object? If it has mass, it has what? Force of gravity. Do you agree with that one?
Yes.
Okay. And we also have a force acting in this direction, which is 80. You can say it's an applied force, I think, but I'm just gonna write it as force applied 80 newtons. And then you also have, do we have a surface? Yes, we do. If we have a surface, what forces are going to act on your object? First one is the normal force. And the second one will be if you have a surface. The second one will be Mamsan, if you have a surface, what are the forces that you're expecting?
So normal force
And
and I don't know, frictional force.
friction. That's true. However, you have a smooth horizontal surface. What does it mean, Mamsan?
That does it mean that there is no friction?
Friction equals 0. Okay. That means we can exclude friction in our calculations. So if we exclude friction, what other force are we going to represent? Force F, which is an applied force. F. And then the angle is 40 degrees. Let me see what you did. Yeah, you got it right. Then they said calculate the magnitude of F. The magnitude of F. So, Mamswan, what is it that we must do in order to resolve or to solve for, which is the applied force?
So don't we need to break the force of F down into its components?
That's true. Do we have a tilted force? This is the tilted force. So the horizontal component of it will be what? F. The horizontal component, it will be F. Kathis. I can see here you did right, but you didn't indicate. So your horizontal component will be F cos of theta. Why is it cos of theta? It is the cos of theta because the horizontal component forms part of the angle. So the limb or the component that forms part of the angle is a cos. And your vertical component it does not form part of the angle. So it means your y will be F sine of theta or F sine of 40 degrees. That's okay. Now, what is the next step, Mamswan? What will be the next step?
So will it not be F sine of theta
We will
minus?
resolve in the x direction, right?
Yes.
And it will be you said F sine of theta.
No, F cos of theta.
F cos of theta plus
force applied. No. Yes, force applied.
this one.
Mm-hmm.
Then
And then is equal to F net.
F net, which is equals to
0.
0. Okay. Why is it that our F cos of theta is positive? Mamswan.
So please repeat your question.
Why is it that F cos of theta is negative?
It's negative.
No, it's positive. You said positive. Why is it positive?
Oh, no, sir. Isn't it negative because it's going in the other direction?
Yes, but you didn't say so.
I'm sorry.
Okay. Do we all agree that our F cos of theta is negative? Katiso.
Yes, I do.
Ronewa, do you agree? Okay, I assume she agrees. So the next step, okay. The next step will be, Mamswan, what will be the next step? What will be the next step? I think we all agree. 80. I am going to take this portion to the other side. So if I'm taking it to the other side, if it's going to cross the equal sign, it will change the sign to positive, which is F cos of 40. So to get F, I will have to divide by cos 40 both sides. So these two will cancel. So F will be 80 over cos of 40, which is how much? Let me check. Um, 80 divided by cos of 40. It will be 104,43 newtons. So do you have any question concerning that?
No, I don't have.
Okay, let me see what you have got. Okay. Calculate the value of X. Calculate the value. Mamsan, how do we go about calculating the value of X? The value of X. The value of X. Now, the questions on forces throughout, they are all about resolving forces in the X and the Y direction. Given that we have not yet resolved in the Y direction, I think that's where we must supposed to go. So if we are resolving in the Y direction, Kafiso, what is it that we're gonna have in terms of the forces?
We will have the minus force of gravity.
Minus force of gravity, then
sine theta
plus F sine theta, then
is equal to
and then normal force, what happened? Are you ignoring it? Or is it redundant? Normal force, you didn't see it. Normal force is also a force. And it's there on your diagram. You are just taking whatever that is there in the diagram and putting it in an equation. You have already extracted force of gravity. You also extracted the component of your applied force. What about the normal force? And what would be the sign of the normal force, Hafiz?
it will be positive.
Positive N. Are we all on the same page?
Yes,
And then it will be equal to what?
F net
F net, which is
equal to 0.
0. Okay, that's great. Now, Fg is it's actually equals to minus mass times what? Mg. Then F sine of 40 plus the normal force. Plus the normal force. Actually, I'm realizing that we did not put. Oh, yeah, we actually put all the forces. Yeah, all of them are in. It's equal to F net equals to 0. 0. So we will have minus. What is the mass? The mass is X. The gravity is 9.8 plus this will be, we already have F, it is 104.43 sine of 40 plus the normal force. Plus the normal force. This is equals to 0. Okay, I'm gonna take everything to the right hand side. Or let me take minus X times 9.8 to the other side. It will be positive. So I'm gonna be left with 104.43 sine of 40 plus N is equals to X times 9.8. Now the x is given by, if I divide both sides by 9.8, I will have x is equals to 104.43 times sine of 40 will give us 104.43 times sine of 40 to be 105.1 plus the normal force all over 9.8. So that's the value of x. Because unfortunately, we cannot solve for the normal force. Because we were not given the normal force. So that's what we have. And the unit is kgs. Does anyone have a question? Okay, if you don't have any question, I'm gonna try to bring my own question. Let me put the whole question up. Okay, we have the following question. It said in the diagram below, a 1 kg mass and a 2 kg mass are connected by an inextensible string of a negligible mass. The string is passed over a light frictionless pulley so that the mass hangs down as shown. Initial system is held stationary. Then they said, draw a free body diagram showing all forces acting on a 2 kg mass. Ronewa, what are the forces that are acting on the 2 kg mass? The first one. The first one.
The force of gravity.
Okay, force of gravity. The second one. Is the tension. Okay. Yeah, that's correct. It's the tension. Now, calculate the time it will take a 1 kg mass to move a distance of 1 meters when the system is released. Now, did you guys use the equations of motion in grade 10? Do you remember the equations of motion? Good time. Okay, now the first thing first, if you are dealing with forces, is to draw a free body diagram. The second thing will be to choose the direction. As positive, sharp. Now, the third step is to go and resolve. Let us go and resolve all the forces in the y direction on the 2 kg block. They said initially the system was held, and it was held stationary, meaning the system is not balanced, but it was held maybe by a hand or something to stop the system from moving, because you can see clearly that the two sides are not in equilibrium. The other side has 1 kg and the other one has 2 kg. So if it has 2 kg, obviously there will be acceleration. The 2 kg will pull down the 1 kg. That's what will happen. In this case, we are sure that there will be acceleration from observation. And we have been told that the pulley is frictionless. What does it mean? It means that the tension on this rope will flow to the other side, and it will be the same as this one. So these two tensions will be the same. Why? Because the pulley is frictionless. I think I have emphasized this for a number of times. Now, Kathy, so how do we resolve forces on the 2 kg block using the free body diagram we have drawn? Kathy.
Okay, we will have the tension.
Tension positive, then
There's positive, then it's like a minus force of
minus
gravity.
force of gravity, and then
after that, we got is equal to F net
F net.
is equal to 0
Why is it 0?
because it is stationary.
Initially, it was stationary, but now we have released the system, meaning that we are allowing the system to be what it is. So it is no longer stationary. From observation, there will be acceleration, because on one side we have a 2 kg and the other side we have a 1 kg. The 2 kg will pull down the 1 kg. Do you agree?
Yes, I do.
Because they said the system is released. So it's not 0, it is mass times acceleration. You agree?
Yes, I do.
Okay. Now they said calculate the time it takes for a 1 kg mass to move a distance 1 meter. So what is it that we need to calculate in this case? Do we have tension? No, we don't have. Do we have force of gravity? I think we have. Do we have it?
Yes.
Okay, so tension minus mg is equals to ma, and tension minus mass. What is the mass? 2 times 9.8 is equals to, the mass is 2 times, do we have acceleration? We don't have. So we will have this as equation number 1. Or let me say tension is equals to 2 times acceleration plus 2 times 9.8 plus 2 times 9.8, which is equals to 2a plus 2 times 9.8 is what? 19.6. Okay, so tension is given by 2a plus 19.6. Okay, that is the tension on a 2 kg block. So if we have the tension on the 2 kg block, we have been told that we are dealing with a frictionless pulley, meaning that your tension will flow. So if your tension will flow, we're gonna have to go to the 1 kg block as well. I'm trying to shift. Okay, now I'm gonna do a free body diagram for the 1 kg. Mamsan, what forces do we have on the 1 kg?
So do we not have gravitational force?
Fg and what?
Tension force?
Tension force. And do you agree that the very same tension that I was calculating is going to be the same as this one? You agree?
So
Yes. So whenever you see problems that involves tension, what they are trying to do to you guys is they want you guys to calculate simultaneous equations, because you're going to be dealing with a problem whereby tension on the other side of the pulley will be the same. So we're going to do almost the same thing we did on the 2 kg. So what will be the first thing first? Ronel, we are resolving in the y. So what is it that we have? Ronel, Kagiso, how do we resolve forces in the y direction on the 1 kg, given that we have a free body diagram?
So I have tension
Tension
minus force of gravity
is equals to
F net
equals to
MA
MA. Why is it MA?
because you said the stationary is released.
Yes, there will be acceleration and its effect. Okay, so we're gonna apply the same thing. We do not have tension. Do we have the force of gravity? What is it, Kagiso?
They have one. I mean MG.
Okay, it's equal to MA. Tension minus 1 times what? 9.8. It's equals to 1 times acceleration. We have tension is equals to acceleration is acceleration. Then if we take this to the other side, it will be a plus 1 times 9.8. This will be A plus 9.8. Let's say this is equation 2. So, Mamswane, what do we do from here? Given that we have two equations of tension, what do we do from here? Equation 1 equals equation 2. Mamswan, do you agree with this? Ronel, do you agree?
Yes, sir.
Because we are dealing with a frictionless pulley. Like I said, the tension on the other side is also equals to the tension on the other side, because we are dealing with a frictionless pulley. So do you agree that given that we have tension on equation 2 and tension on equation 1, I can just take this portion and this one and equate them? Mamswan, do you agree? Do you agree with this statement?
Yes, sir.
Okay. 2A plus 19.6. If I take, okay, I will take 19.6 to the other side, it will be a minus. Then if I take A to the other side, I will have it as minus 2A. Do you agree? Okay. 9.8 minus 19.6 minus, let me see. Okay, 9.8 minus 19.6 will give us, let me check. Minus 9.8. Minus 9.8 will give us acceleration. So acceleration is equal to minus 9,8 meters per second square. Now, given that we have the value of acceleration, Kahiso, what do we do from here? If we are solving simultaneous equations, have you guys done simultaneous equations?
Yes, sir.
So what do we do if we have solved one of the component of the simultaneous equations?
So can't you substitute it into the other equation?
That's correct. Now I'm gonna choose the easiest equation, which is T equals A plus 9.8. A plus 9,8. This will be, the value of A will be minus 9,8 plus 9,8. It is giving me 0, which I'm doubting my answer, but the process was right. So I'm gonna go back and review where I possibly did wrong. I'm gonna go and check where I did wrong, because there's no way our tension is 0. Let me try to see where we made a mistake. Tension positive, 2 times minus equals mass times acceleration. Okay. Then the top one, we had 1 kg. I'm trying to check where we possibly made a mistake. Okay, let's just assume that the tension is correct, is 0. Given that we have an acceleration of minus 9.8, let's just say if the acceleration is minus 9,8, that means it will be 9,8 downwards on the 2 kg. and it will be 9.8 upwards on the 1 kg. It will be upwards because the 2 kg will pull down the rope, and the 1 kg will be pulled up. So what will happen is that if we use the equations of motion, we have acceleration and we are looking for time. And we also have the initial velocity, which is 0. We also have the change in y. So if you go to the equations of motion, the equation of motion that relates acceleration and time, it will be, let me look for it. Equations of motion. Or do you have it in mind? Mamsa. It will be
Vf is equal to Vi plus A times the change of time.
okay. Let me write it down. You said it will be. You said it will be Vf is equals to V initial plus
acceleration
times time.
and change of time.
We can use that one as well. So we will have V initial, it will be 0 plus acceleration is 9.8 upwards times, what is the time? Do we have the time? We do not have the time. So this one fails. Do you know of this one? I think it's UT. Do we have the time? Let me see which ones we have. Okay, why don't we use, there's this one that I'm seeing. V final squared is equal to V initial squared plus 2 acceleration times change in y. Do you think this will work?
Yes, sir.
Okay, we are looking for Vf squared final is equal to V initial was 0 squared plus 2 times acceleration is 9.8 times change in y is 1 meters. V final will be 2 times 9.8, which is 19.6 meters per second. So we have V final. So if we have V final, we can go back to your equation, this one. V final will be 0 plus 9.8 times time. So we have V final, which is 19.6 equals to 9.8 times time. So time will be equals to, we divide by 9.8, both sides. We will have 19.6 divided by 9.8, which is, I think it's 2. Yeah, I got 2 seconds. So it will take 2 seconds for the 1 kg mass to move a distance of 1 meter. I think that's it for today. I'm gonna see you guys next week, Tuesday. So I'm also gonna send you guys a homework which you're gonna have to submit on Google Classroom. So once you have submitted, I'll go and mark all your homeworks, and then when I do my lesson next week, it's gonna be based on the homework. Okay, so I'll see you guys next week. Tuesday. I'm also gonna upload the videos that I have recorded on the last lessons. I didn't get enough time to do so, but I'll do so. Also, I will share the solution for today's lesson. All right, see you guys next week, Thursday.